Good day, viewers at home. Welcome to Home Learning. This is SGCSE Mathematics. You are with Mr. Dlamini. I hope students at home are ready to solve problems. Right, without wasting a lot of time, we can have a look at our first question. Once again, in our lesson here, we're going to continue with our revision. Hope you will enjoy the lesson. Right, now let's have a look at the first question here. So it's a question on matrices. Right. So the question is as follows. You are given two simultaneous equations. You are given two simultaneous equations, and you have to write these equations in matrix form. Right. So you have the first equation here. It's 2h minus k is equal to negative 2. That's our first equation here, a 1. And then you have the second equation, which is negative h plus 3k is equal to 1. Right. So that's our equation 2 then. Then how can we write these two equations in matrix form? If you remember very well, in order to write these two equations in matrix form, you have to first identify the coefficient matrix. The coefficient matrix is this matrix which is formed by the coefficients of the two variables here. So our variables, it's h and k. So you can look at the first equation and note the coefficients. That is the coefficient of h here, it's 2. And looking at the first equation, what's the coefficient of k? So if you look at that first equation, your coefficient of k there, it's just negative 1 there. Right. Similarly, considering the second equation now, what's the coefficient of h? So you should be able to note that the coefficient of h there, it's once again negative 1. And looking at the coefficient of k in the second equation, it's your 3 there. Meaning that your coefficient matrix now, you can write it here, starting with the coefficients of the that is the coefficients of the first equation. It's 2 for h, that coefficient is 2. And then you have negative 1, which is the coefficient of k in the first equation. Then looking at the second equation, what's the coefficient of h? It's negative 1. And the coefficient of k in that second equation, it's what? You can see that it's a 3. Right? And then you can have the two variables. So the first variable, it's h there. So the first variable is h. And the second variable is k. That's equal to, then looking at the right hand side of each equation, in the first equation, you have negative 2 on the right hand side. And here you have 1. So that's how you can write these two equations in matrix form. Right. So once again, here to write simultaneous equations in matrix form, you have to identify the coefficient matrix. That is a matrix formed by the coefficients of the variables in the two simultaneous equations. Okay. Now we can look at the second part of the question here. It's find the inverse of the 2 by 2 matrix. Find the inverse of the 2 by 2 matrix. Here we're referring to this matrix here. It's a 2 by 2 matrix. So what's the inverse of this 2 by 2 matrix? In order to work out the inverse of a 2 by 2 matrix, once again, you first have to calculate the determinant. We can work out what we call the determinant of that 2 by 2 matrix. Then how do we calculate the determinant? Well, the determinant is the product of the numbers on the leading diagonal. In this case, is that product 2 times 3. Those are the two elements along that leading diagonal of the 2 by 2 matrix is the product of the elements along the leading diagonal minus the product of the elements in the other diagonal. So in this case, the other diagonal is -1 times -1. So those are the elements in the other diagonal. Then if you work out this, you should be able to find 6 minus -1 times -1. That's 1. Therefore, your determinant is 5. Yes. To calculate the determinant, we are saying it's the product of the elements in the leading diagonal minus the product of the elements in the other diagonal. Then you can work out that to get what we call the determinant. Okay. Now, we want to get the inverse of that 2 by 2 matrix. Right. Then the inverse is always, the inverse here is always 1 over the determinant. 1 over the determinant. In this case, our determinant is 5. So it's 1 over 5 times. Then you look at the leading diagonal. So we have a 2 there and a 3 down here. So you can swap those numbers, meaning that you write a 3 there and a 2 there. So you swap those numbers on the leading diagonal, and on the other diagonal you don't swap, but what you do, you change the sign of those values there. So meaning that here, instead of having -1, we'll change the sign to be positive, and here we'll change the sign to be positive there. So if the sign is negative, it changes to positive, and the other way around. Okay, so that's our inverse here. Then the third part of the question is hence solve the matrix equation to find the value of h and k. Hence solve the matrix equation to find the value of h and k. Right. Here we have to use the matrix method for solving simultaneous equations. Already we have written our matrix equation here. But then how do we proceed to find the values of h and k? In order to find h and k, we have to solve this matrix equation, which is given in the first part of the question. Right. So if we write it down here, the matrix equation, it's 2, -1, -1, 3, multiplied by its hk is equal to -2, 1. So that's our matrix equation. Then what we do here, we have to use the inverse to solve this matrix equation. What we'll do, we'll just multiply by the inverse on the left, both sides. We multiply by the inverse on the left, both sides. So meaning here, we start with the inverse. So our inverse, it's 1 over 5, 3, 1, 1, 2 there. Starting with that inverse, then we can write this down here. It's 2, -1, -1, 3, multiplied by hk there. So we've multiplied by the inverse there on the left. That's equal to, similarly, on that right hand side, here we multiply by the inverse. That becomes 1 over 5, 3, 1, 1, 2, multiplied by -2, 1 there. Right. So that's the result once we multiply by the inverse, both sides on the left there. Then if you work out this product, if you have a matrix A multiplied by A inverse, that should be always equal to the identity matrix. Similarly, if you say A inverse multiplied by A, that should be equal to our 2 by 2 identity matrix. So similarly here, because the inverse of this matrix, it's that matrix on the left, then multiplying the 2, we expect to get our 2 by 2, the identity matrix, which is 1 0 0 1 there. Multiply this by HK, that's equal to, then on the right hand side we can do the multiplication. So we'll start by doing that multiplication there, followed by multiplying out by that scalar 1 over 5. So if you multiply this 2 by 2 matrix here and that matrix there, what matrix are we going to get? Remember, multiplying here, you multiply the first row, that row there, by the column matrix on the right. So here it's 3 times negative 2. 3 times negative 2, that's negative 6, plus 1 times 1, it's 1 there. So negative 6 plus 1, your answer there should be negative 5. Then multiplying that second row now with the column on the right, you'll say 1 times negative 2, that's negative 2, plus, then that 2 multiplied by 1, it's 2 there. So your negative 2 plus 2, you're going to get a 0 there. Right. Now, if you do the multiplication this side, it's 1 times h, which is h, 0 times k, that's 0. So you have h plus 0, you're going to get h there. Similarly, multiplying this row with the column there, it's 0 times h, which is 0, plus 1 times k, which is k. Then we have k plus 0, that gives k there. So multiplying that matrix hk by the identity matrix, you'll get that matrix hk. Now, on the right hand side, we can multiply by the scalar, meaning that we'll say 1 over 5, that scalar 1 over 5, multiply it with that negative 5. So what's 1 over 5 multiplied by negative 5? You should be able to get a negative 1 there. And then when you say 1 over 5 here multiplied by the 0 there, you get 0. So therefore, the value of h here, h is equal to negative 1, equating the corresponding elements there. H is equal to negative 1, and k here is equal to 0. So that's the solution of this pair of simultaneous equations using the matrix method. Once again, when using the matrix method, you start by forming the matrix equation here. Given the two simultaneous equations, you can use the coefficient matrix to form a matrix equation. Once you form that matrix equation, you have to find the inverse of the coefficient matrix. Then you post multiply, that is on the left hand side, both sides of your matrix equation, you post multiply by that inverse, as we've done here, multiplying by the inverse both sides. A matrix multiplied by its inverse always gives you the identity matrix. Okay? So basically that's how you can solve simultaneous equations using the matrix method. Okay. Now we can have a look at the second question here. So that's the second equation. In fact, that's the second question. It's find the gradient of this line. That's the second equation here. It's find the gradient of this line. So this is the line here. We are given the equation of the line. Right. Then how do we find the gradient of this straight line here? If you remember very well, the general equation for any straight line, it's y equal to mx plus c, where that m there, it's our gradient, and that c there, it's our y intercept. So the c there, it's our y intercept. Meaning that if we can transpose this equation and make y the subject, we can have an equation of this form: y is equal to mx plus c. And we can then look at that coefficient of x, and that coefficient of x will give us the gradient. So meaning here we have to just change the subject here to y there. So how do we change the subject to y? First multiply both sides by a 5. Multiply by a 5. You can cancel out that 5. You remain with x minus 7y equal to, what's 11 times 5? That's 50, 55. Right. We are changing y. We are changing the subject to y here. Now looking at the y, it contains a negative coefficient, which is negative 7. We can add that 7y both sides to ensure that that y there has a positive coefficient. So the result will be 55. X is equal to 55 plus 7y here. And then now the term involving x is that term there, 7y. That's the term involving x here. We can take that 55 across. What will be the result? You'll have x minus 55 is equal to 7y. In order to remain with y here, can simply divide by a 7. Here, you can divide each term there by 7. Cancelling off here, you have y is equal to x over 7 minus 55 over 7 there. Then what's the coefficient of x here? Because this equation is of the form y is mx plus c. So you should be able to see that your m here is that coefficient of x. So what's the coefficient of x here? Basically, it's 1 over 7. And your c here, which is the y-intercept, is equal to negative 55 over 7. So therefore, the gradient here of this line is that m there, which is 1 over 7 there. So the gradient of this line is 1 over 7. Once again, looking at this problem, you have to make y the subject so that you can compare the resulting equation with the general equation of a straight line, which is y is mx plus c. Okay. The question reads as follows. A survey was carried out to determine the number of people who owned a car C, a television set T, or a bicycle B. A total number of 650 people took part in the survey. 515 people had a car. 542 people had a television set, and 228 people had a bicycle. You also given that 480 people had a television set and a car. 150 people had a television set and a bicycle. 125 people had a car and a bicycle. And 110 people had a television set, a car, and a bicycle. Copy and complete this Venn diagram to show this information. Right. So looking at our Venn diagram here, you can see that there are several missing elements in these sets. Once again, we have the set C here, which represent people who owned a car. The set B here represent people with a bicycle. And the set T, which is our third set, T there, are those with a television set. Now, you are given that the total number of people or the total number of elements in C, it's given here. It's 515 and 228. That's the total number of elements there in B. In the universal set, the total number there is 650. And in the set T, the total number of people is 542. Then we have 480 people had a television set and a car. So the 480 people had a television set and a car. That means these members are in T intersection C there. Television set and a car. So the intersection of those two sets is just there. So that's the intersection of the two sets, T and C there. So the total number of people within this set here, that should be 480 there. But already you are given this 110, those people who owned all three. So here, in order to get the number of people here in this space there, so we'll say 480 minus 110. If you work out that, 480 minus 110, you'll get 370 there. So that's 370. So the 370 plus the 110 gives that 480 people, which are the people who own both television sets and a car there. Similarly, 150 people had a television set and a bicycle. That means T intersection B there. So the total number of elements in T intersection B is 150. 150. So therefore, we can identify this region, T intersect B. So you can see that it's that region there, over there. So that's the region T intersect B, right? Then how many elements are in this space here? If the total number of elements is 150, then you'll have 150 minus 110. If you work out that, 150 minus 110, should be able to get 40 there. So we have 40 there. Then we have 125 people had a car and a bicycle. That means C intersection B, the number of elements there. So having the number of elements in each of those three sets there. So the number of elements in C intersection B, that should be 125. So you can identify C intersection B which is that part there. So that's the part C intersection P. And then 125 minus 110. You can work out that. 125 minus 110. You should be able to get 15 there. Then you can see that there are still some missing figures here. So if we name them, maybe this is our W there. Maybe this one will be X. This one may be Y. And that one may be Z. So basically there are 4 missing figures in order to complete these sets here. So starting with our X. So your X will be equal to, you can see that the total number of elements in that set C there should be 515. So your X will be 515 minus, it's 515 minus, then you can find the sum of the 3 elements which are within that set. That is 370 plus 110 plus 15 there. So if you look at 515, you can work it out. It's 515 minus, it's 370 plus 110 plus a 15 there. You will be able to get X here is equal to 20. So therefore, here you have your 20 there. Similarly, we can work out Y here. To find Y, so your Y will be equal to, your Y will be equal to, it's the total number of elements in T there, which is 542 minus the sum of the elements in T there, which is 370 plus 110 plus 40 there. So if you work out Y, it's 542 minus 370 plus 110 plus 40. If you work out that, you get your 22 there. So in that space Y there, or in that region, you must have 22 elements. Similarly, you can work out your Z. So Z is equal to what? We can write it here. Z is equal to the total number of elements in P there, 228, minus, then the sum of the elements within P there, it's 15 plus 110 elements plus 40 elements there. If you work out this, it's 228 minus, it's 15 plus 110 plus 40. That's equal to 63. Right. So once again here, you can easily complete this 3 here, because we have to deduct, that is from the total number of elements in each set, we have to deduct the 3 elements which are already in there in order to get the missing figures there. The last value we have to find here is that value of W. Those who have none of the 3, they have neither a television set, nor a car, nor a bicycle. So your value of W here, can work out W. The value of W, it's W is equal to, you can look at the total number there of elements in that universal set, which is 650 there. So we can have 650 minus, we can pick one set, maybe minus that set T there. So in set T is 542 plus, then because the 542 is the sum there, 370 plus 110 plus 40 plus 22. So meaning that from the 650, we have to subtract that sum there, which is 542 plus, then we have these three other elements which have to deduct from the total number of elements in the universal set. So it will be 650 minus the 542 plus 20 plus 15 plus Z there, which is just 63. So it's plus 20 plus 15 plus 63 there. So it's 650 minus 542 plus 20 there plus 15 plus the last one is 63 there. So you should be able to find the value of W there, which is 10. So that's the value of W. Right. Now you can find the number of people who had Roman 1, a television set and a car, but not a bicycle. A television set and a car, but not a bicycle. Looking at this, it's a television set, which is T there, and a car, but not a bicycle. Meaning that we are considering the set here, T intersect C here. So we want to get the number of elements in T intersection C. We've worked it out. In fact, we are given there. The number of elements in T intersection C, that's 480. So meaning here, because it's a television set and a car, so we have that 480 there. So here, it's 480 there. But amongst these 480, there are those with a bicycle. So to find the number of elements or the number of people with a television set and a car, but not a bicycle, because looking at this 480, it includes those with a bicycle. So we can deduct that. So we can say 480 minus 110 there. So we did calculate this, 480 minus 110. So that will be 370 there. So this 370 is the number of people with a television set and a car, but not a bicycle. Right. So amongst the people with a television set and a car, there are those with a bicycle. So we deduct those and get that 370 there. Find the number of people with at least two of the items. At least two of the items. When we say at least two here, what do we mean? At least two of the items. When we say at least two of the items, we mean it can be two items or even more than two. So to find this number of people, you'll add 370 It's 370 plus 110. So that 110, they have all three, plus the 15 people they have two items. It's plus 15 plus this 40 here are those people with two items, because the 40 there are those people with a bicycle and a television set. So adding this, that is 370 plus 110 plus 15 plus 40 there, you'll get 535. So that's the answer there. It's 535. Those with at least two items. Then you work out the number of elements here in C union T, union B, complement. So it's the number of elements which are outside the three sets A, that is C, B, and T there. So in this case, it should be just 10 elements. So it's only 10 there which are outside the three sets. But C union T, union B complement means outside the union of those three sets. So we'll get 10 people there. The last part of the question, it's find the probability that one of the 650 people chosen at random had only one of these items. Then we can look at the favorable outcomes here. One of these items. So we'll pick those with a television set only there. They are favorable. They have just a television set. Similarly, those with a bicycle only and those with a car only. Then if we sum up the people with exactly one item, that is the 20, it's 20, those with a car only, plus 63, those with a bicycle only, plus those with a television set only, which is 22. If we work out that sum there, we can work it out. It's 20 plus 63 plus 22. So the sum there, it's 110. You can write it down. It's 105. Then we can find the probability that the person chosen at random there amongst the 650 had only one of these items. So meaning this probability, so the probability of having one of the items is equal to, so the probability of having one of the items is equal to the 105 over the total number of people, 650 there. Then you can simplify this 105 over 650. If you simplify this, you'll get 21 over 130 there. Right. Okay. So basically to find this probability, what we are saying here, you first have to get the number of people with exactly one item. In this case, it will be just 20 there plus 63 plus 22 there. Once you you get those with exactly one item, the probability is actually you are choosing out of 650 people, so the probability will be only 105 people out of 650 there. And then you can simplify. Right. Looking at the next question here. So the next question, a solid cone shaped cangle of height 20 centimeters and radius 12 centimeters is molded, or it's melted down and cooled to form a cylindrical cangle of the same height, 20 centimeters. Work out the volume of the cone-shaped cangle here. So are given the cone-shaped cangle, then how can you get the volume of this cone here? So you can see that the cone here, if that's the center, so that radius there, it's actually 12. That's the radius R of that cone there. Then to get the volume, so it's the volume of a cone is equal to 1 over 3 pi r squared h. So that's the formula there. So it say V is equal to 1 over 3 pi r squared h there. Then in this case, we are given the radius and the height. The height of this cone here, that perpendicular height, h there, is equivalent to 20. So we can substitute into that formula. So it's 1 over 3 pi times 12 squared, which is the radius square, times 20 there, which is your height. Then you can work out that it's 1 over 3 multiplied by pi, multiply this by 12 squared, and multiply that by 20. Your answer there will be 3015.93. So looking at your answer there, you can round it off maybe to say the nearest whole number, meaning that looking at that 9 there, you can add 1 and get 3016 cubic centimeters there. So that will be the volume of this cangle, which is cone shaped. Once again, we just substitute into that equation. V is equal to 1 over 3 pi r squared h. Right. Then what is the radius? What is the radius of the cylindrical cangle? So now we want to determine r there. So we have to note that V here is 3016. So here, because we are melting down this solid here, cone, in order to form that cylindrical cangle, so that's why we get the same volume there. So meaning that the volume of the cone is the same as the volume of the cylinder, because the cylinder is formed out of the liquid you get once you have melted down that cone there. So they'll have the same volume. Then now, given the volume of the cylinder, how can we get the radius? Here, you have to recall the equation for finding the volume of a cylinder. If you remember very well, volume of a cylinder V is equal to pi r squared h there. So that's a volume of a cylinder. Right. So in this case, it's V is equal to pi r squared h, and then you want to get the radius. That's the question. What is the radius? Meaning that you have to make r the subject. So looking at this equation, how can you make r the subject? You just divide by pi h here, divide by pi h here, cancel out the pi, cancel out the h, you get v over pi h equal to r squared. So that's the result. V over pi h is equal to r squared. And then to remain with r, we can take the square root there. What's the square root of r squared? That's r equal to a square root of v over pi h there. So that will be your r. Then you can then work out the radius because you already know the volume. You already know the height of the cylinder. So this will be a square root of the volume, which is 3016 over pi h. So here it's over pi multiplied by the height h, which is 20. If you work out this square root, it's a square root of 3016 divided by pi times 20. That will be 6.93 centimeters. So that's the radius here. Once again, you have to note that in answering this question, you have to look at the two solids. That is the cone and the cylinder. They have the same volume, which is 3016 there. Then the fact that they have the same volume, to find the radius of the cylinder, you use the formula for calculating the volume of the cylinder there, making r the subject. Then you can substitute the figures and get your 6.93 centimeters as your radius. Okay, the last part of this question, it's calculate the total surface area of the cylindrical kangle. Calculate the total surface area of the cylindrical kangle. To get the total surface area of a cylinder, we have to recall the formula. What's the formula for getting the total surface area of a cylinder? Your formula will be 2 pi r squared if the cylinder is closed at both ends. It will be 2 pi r squared plus pi dh, or this term here, you can write it as 2 pi r h, because pi times diameter, which is the circumference, is the same as 2 pi r, because the diameter is 2 times the radius. Now, looking at this equation here, you can substitute the figures. It's 2 times pi. The radius is 6.93 squared plus pi times 2 there. So this diameter, as we have said, is 2 times the radius. So it's 2 times, your diameter will be 2 times 6.93. That's your diameter, 2 times 6.93 times the height h there, which is 20. Then you can work out this. It's 2 pi times 6.93 squared plus 2 pi it's 2 pi times 6.93 times 20 there. So your answer there will be 1172.6, which is approximately 1173. The surface area there, it's in square centimeters there. So once again here, we are using the formula for getting the total surface area of a cylinder. So we have to know this formula by head. It's 2 pi r squared plus pi dh, or plus 2 pi rh. Okay. Now we can move on to statistics. So this is our question on statistics here. We have to answer this question. Normally you answer it on a graph paper because we have to draw. 40 teachers were asked how much they spent on airtime per week. The following table shows their responses. So you can see the amount spent here is actually grouped. So we have group data. So the first group is within that range, 20 to 25, they are 7. And then 25 to 30, they are 9. And 30 is less or equal to A, less or equal to 35, they are 12. And so on. That's the information from that table. Then using a scale of 2 centimeters to 5 units on each axis, draw a frequency polygon to represent this information. Then how do we draw a frequency polygon? So normally students confuse a frequency polygon with a cumulative frequency curve. So here we are required to draw a frequency polygon, not a cumulative frequency curve. Meaning that we are going to use that variable versus the frequency here, which is number of teachers. Then how do we get our ordered pairs here? We use the mid values. So we use the mid values of each group. Like looking at the group, 20 is less than or equal to A, less than 25. What is the meekly value or the mid value of that group there? To get the mid value, you add the lower class value plus the upper class value divide by 2. So meaning that 20 plus 25 divided by 2, you'll get your 22.5. Then you can work out the mid values for each of these groups. So here it's 22.5, that's the mid value. Between 25 and 30, our mid value will be what? So we'll get the 27.5. Similarly, if you work out the mid value for that group 30 to 35, you'll get your 32.5. And the mid value for that group 35 to 40, that's 37.5. And the last group, which is 40 to 45, our mid value will be 42.5 there. So your ordered pairs there, it will be that 22.5 versus the frequency, which is 7, 27.5, comma 9, 32.5, comma 12, and so on there. That is 37.5, comma 7, 42.5, comma 5. But then our graph must touch the x-axis. Our graph must touch the x-axis. So we can add 2 points here. We'll add 1 point on this side, and we'll add another point just below 20 there. So meaning that looking at the group interval is 5 there. So we have 20 to 25. So that range is 5. 25 to 30. Once again, the range is 5 throughout. So looking at the group there, which is lower than 20 to 25, we can add another group there, which is just 15 to 20 there. So what will be the mid value of a group 15 to 20 there? So that mid value there, if you say 15 plus 20, divide by 2. So you'll get 17.5, meaning that this side, our coordinate will be 17.5, comma 0 there. For our graph to touch the x-axis there. Similarly, here, above 45, so we'll say 45 plus 5, which is 50, meaning the group is from 45 to 50 there, and our mid value there, 45 to 50, so we'll have a coordinate there, 47.5, comma 0 there. So note that we have to add those two coordinates for our graph to start on the x-axis. Right, now we can have a look at the resulting graph here. You can look at the resulting graph. So in this case, we have our frequency polygon. Once again here, we have the amount here. So on the x-axis, we have that amount of airtime there per week. So that's the amount per week. The amount spent is indicated in the table in Emalangeni. So that's the amount spent in Emalangeni, and on the vertical axis, that's our frequency. Right. Then we can look at our points. As we have said, the first coordinate is at 17.5, 0 here. So it's 17.5, 0. And then the next coordinate, we've said it's at 22.5, which is just there. 22.5, the frequency there, it's 7. The next coordinate, it's at 27.5, it's just there. And the next coordinate is at 32.5, which is there. It's 32.5, 12. The next coordinate is at 37.5, there, 7. And we have that coordinate at 42.5. That coordinate there is at 42.5, 5. And the last coordinate is at 47.5, 0. You can see that when drawing a polygon, you can then join those coordinates with some straight lines as illustrated in that graph. So that will be your frequency polygon. Right. That's all for today. I hope you enjoyed the lesson. Until we meet again, have a good day.